Good morning, everyone. Welcome to Las Vegas. Welcome to MIX. And thank you for coming to my very early session. I'm really glad that I'm not giving this talk yesterday morning, after the attendees party. That would have been disastrous for me. So, as a software developer, once in a while, you come across one of these projects that really changes your perspective on how to do the development process. And for me, it was a project that I was responsible for before I joined Microsoft. I had the opportunity to work on the United States Postal Service point-of-sale system. I was responsible for the architecture on that project for a large hardware company. And what was interesting about that project was the way that this company approached the proposal for the contract. Instead of just selling the system on kind of hardware costs, maintenance costs, scalability, total cost of ownership, they put together a team of usability engineers at the start of the project, and they really studied how the postal workers went about their workflow and what would be more productive for these guys. And they put together the proposal by coming up with a really good design for the hardware and the user interface for the project. And that was what they sold the United States Postal Service on. And when I came into the project, I was responsible for kind of helping them put together the software system. And the first thing I did was to talk to these usability engineers. And two things kind of came up and that really kind of changed the way that I approached the architecture of the product. And so the first thing was they told me that, well, the user interface, yeah, you have these nice screenshots now, but guess what? They're going to be changing throughout the cycle of your development process. You would be expecting the UI to change right towards the end of the project, because what we're expecting is we're going to expect as you bring kind of features online, we'll take it out to the postal workers and do field testing on them. And we're expecting that people will be wanting to change the layout, the types of information that goes on the screen, the workflow, and we'll be doing that throughout the various functionality of the product. And the second thing that that really kind of struck me was they told me that, well, not only are we going to change the user interface and the workflow during the development process, they're going to do it after the system has been deployed. And the reason for that is that there are new postal regulations all the time. The post office was likely to get into new lines of business, so the regulations will change. Perhaps the steps in the workflow. There are going to be all sorts of stuff that needs to change from the user interface perspective throughout this, the life cycle of the application, not just during the development process. So it occurred to me that what we really needed was not the traditional type of software development process where the designers or the usability engineers come up with a bunch of screenshots and hand it over to the software developer, and then they go and build the system and hand it back. Because these usability engineers needed to actually try different variations of the user interface with the real customers, and they need to be able to do that themselves. So that had a lot of impact on the way that we design the application. So first, we needed the engineers, these usability engineers, to be part of the development process. They will be building the user interface at the same time as the software developers building the business logic and building the infrastructure to support the user interface. So they needed a way to be able to do that themselves. And keep in mind that this is during the NT4 time frame. The application was built on MFC and COM. That was kind of the state-of-the-art technology. So certainly, these usability engineers were not going to be writing GDI code and laying out the screen. So we needed to come up with something that allowed them to to manipulate the UI. So in the end, we came up with a system that probably sounds quite familiar today. We have some text file that allow you to lay out the user interface, and the user interface elements are bound to the underlying COM objects in those days by property names and table names, and we even had a declarative kind of state machine to drive the workflow. And so fast forward to today, obviously a project like that, a lot of time was spent on actually building this framework. But today, we basically have the same type of stuff on WPF and Silverlight, for free. It comes out of the box. And, we have kind of built the infrastructure with XAML that allows you to have your development tool and your designer tools kind of work on the same, solution. And so we have this really good workflow. And I think that really kind of, that project really changed how we approached, software development. So my name is Anson Chow. I'm a senior program manager with the WPF team. And this talk today is going to be talking about the data services that WPF and Silverlight provides. So data is everywhere. The role of the user interface is really to let the user visualize this data and interact with it. And if you look at all these applications here and the applications that Scott Guthrie showed on the keynote, they have one thing in common. They all use data binding to connect the user interface to the underlying data models. So what is data binding? Well, data binding is a mechanism that connects a part of the user interface to objects in memory. And the part of the user interface is called the target. And the objects in memory are called the source. And so what can be a target? The target has to be a dependency property on a dependency object. And dependency properties is a new concept introduced by WPF. They're similar to the properties on a CLR object in that they hold a value. But they also add other functionalities, such as data binding, animation, styling, and triggers. And in fact, most of the properties on WPF UI elements are dependency properties. That means that they can be target to data binding. And what can be a source? The source can be anything that is in memory. So in fact, just about any CLR objects could be the source for data binding. So a lot of people think that data binding is about connecting the user interface or displaying data from a database. In fact, that's not quite true. In order to display data in the user interface in WPF, you have to bring that data into memory as CLR objects. And so if you wanted to display data from a database, then you need to use a technology such as ADO.NET, Entity Framework, Link, to bring that data into CLR objects. And at that point, you can data bind to the WPF or Silverlight user interface. And the same is true for bringing in data from, let's say, web services. You'll be using something like WCF. And the reason why we do this is then you can really data bind to just about any type of CLR object in memory, including things that you build yourself. So let's take a look at what it really means to do data binding. So throughout the talk, I'll be giving a series of demos, and they're all based on the same data model. And so we'll start by just taking a quick look at that. It's a very simple model of the solar system. So we have a solar system that has a collection of suns and planets, and they all solar system objects, and we have derived the sun and planets and moon from them, and planets can have a collection of moons. So it's a very simple data model, and we implement it in just plain old C#, and we pre-populated it with some data. So for this particular example, we just hard-coded the data for our solar system, but you can imagine that the same model could be populated from a database or any other source that you want, XML, for example. So for the first example, we would just take a look at what it takes to data bind a set of properties onto the user interface so that you can display the data from these objects, as well as pushing data back into the object. So we'll start out with a very simple form, and in fact, what I'm going to do is that I started this particular Visual Studio solution from Visual Studio, and I've also opened it in Expression Blend, and we'll do most of the first example in Expression Blend. So this is the same solution that's opened in Blend. And what I've done is basically laid out a very simple form with a text field for the name of the of the planet or the sun, going to be an image placeholder, obviously, for the image of the sun or planet, and then a field for the diameter. So the first thing we have to do for this user interface is to bring the object into a place where the user interface can get at this instance of the object. So what we do that. Oh, I probably should have done this first. Give me a sec. So the first thing we do this is that we're going to add the solar system object into a resource of this particular page. So I can do that by going to the data pane and selecting the solar system object. And what that does is that adds this particular object into the resource dictionary of the page. And the key for this is solar system data source. Now, the next thing I'm going to do is to start connecting these text fields into the properties of, I'll connect it to the sun, for example. So I can do that by first selecting a particular control, going to properties, and now I want to data bind the text property to the name property of the sun. So I would just type, oops, excuse me. I type on a Dvorak keyboard, so sometimes when I change different keyboards, I get a little confused. So here, right now, the property is a static property with a value name. And I'm going to click on this, and I'm going to choose data binding. And now it shows me that I already have a data source associated with this, and it's a solar system, and I'm going to pick the sun property. That's a sun object, and I'm going to pick name. And now you can see that this is live. That's the interesting thing about using Blend and also the WPF designer on Visual Studio. These are live objects. The object is actually the object, the sun and the solar system objects are actually running in the background, so you get real feedback. So now for the image, it's not the text. I want to bind. The image source to the image property on the sun. So here I'm going to choose data binding again, and solar system, I'm going to bind to the sun, and now the image is a URI, property is a URI, so I now select it. Now that's actually picking up the image based on the URI that is returned by this particular property. And I'll do the same thing for the diameter. You're going to get tired of me typing wrong in this session pretty soon, I'm sure. All right. So if we actually run this, you're already seeing the result of that. These are actually the values returned by the property. And if I actually change this value and do kind of tap out of it, this actually sets that property, the value of that property, back into the Sun object. So there are other things that you can do with data binding. This is kind of okay, I can get data out, but they're more interesting you can do. One of the differences in WPF from other data binding you're used to is that you can data bind not just to, let's say, the text property of the text box. You can data bind to other properties as well, such as opacity, maybe the rotation angle of your controls. So there are a lot of stuff that you can do that really changes the way that you architect your application because of data binding. Now you can actually have the UI pull values out from your data model and not having to write the code to actually change these values yourself. It can all be done declaratively. So let's go here and I'm going to uncomment a slider control. And let me save this back. And you notice that these are, I'm getting changes from the Visual Studio and Blend. Now I've got a slider control. So what am I going to do with this? So I'm going to take the image, and now I'm going to go to the transformation of this image, a render transform. I'm going to take a look at the angle property of the render transform, and now I'm going to data bind this. Now instead of data binding to a data object that that I implemented, I'm actually going to data bind to another UI element on the on your page. So in this case, I'm going to data bind to the element property of the slider and the value of the slider. Now if we run this, now when I move the slider, now the rotation angle is now bound to my slider. So you can see how you can really use data binding for not just the values of stuff that you display, but you can use it for changing the opacity of that. You can be changing the angle position, and we'll see that throughout the demo on how to reuse data binding to really change the way that you interact with the user interface. So before I leave this particular demo, you notice that here I have shown the diameter in kilometers, but in the United States, people would rather see this in miles. So there are two options for me on how to do that. One, I could add a new property, on my solar system object that says diameter in miles. But that now I'm starting to bake in some UI aspects into my data model, and that's not so nice. So what I would like to do really is to say I want to be able to take my diameter in kilometers, and without changing my solar system object, I want to be able to convert that value. So the way I do this is I use something called a value converter. So let's take a look at what that means. Let's go back here. So in this code, I've added a class. This class could be in any assembly that is referenced by the project. I happen to put it with my class for demo purposes. But it's a standalone class. It says convert kilometers to miles, and it's an I value converter. And it has two methods to override. One to convert it 2 kilometers, and the other one going back. So this is going to be used for the two-way binding on getting value in and out of the text boxes. So now this is a public class, so that's available to me. And I'm going to go to my my XAML page, and I'm going to uncomment some code to give me a field for the diameter in miles. So here I have that. So now for data binding, I am going to go to the properties. Again, I'm going to data bind to text. And I'm going to do data binding. And we've gone through this before. Go to sun, go to diameter. Now, the other thing I'm going to do is I want to incorporate that value converter that you just saw into this binding. And I can do that by selecting the convert kilometers to miles. So a little bit of details. I've already added this particular converter as a resource, onto my page. That's how Blend was able to find this. So now I have two fields, and you can see that these are live data by, when I change one, they kind of change the other. And so you can see with very little code, I'm able to get the types of interactive UI that is typically requires kind of coding to do. All right. So let's take a look at what we actually did. So the first thing that I had to do was to incorporate the solar system object into somewhere that the user interface can find. And the way that I did this was I added it to the resource dictionary of the page. The resource dictionary, every UI element in WPF has its own resource dictionary. It's basically a dictionary of key value pairs. And the interesting thing about the WPF resource dictionary is that not only can you find the values in your particular resource dictionary, you can also find these values in the parent and the parent's parents all the way up the WPF tree. And this is how you can provide resources that are common to a group of kind of UI or even at the level of an application. And so this is how we kind of distribute data throughout a WPF application. So in XAML, what XAML does is XAML just instantiates CLR objects. So we could have put the solar system object directly in XAML. In fact, that would have worked. That means that when we load that page, the XAML parser will basically just create an instance of that particular solar system. However, you don't necessarily always want to create it at the time at which the page itself is loaded. So we have something called the object data provider. So this object is essentially a factory for the object type that that's shown here. So here it says the name of the particular instance of object data provider is solar system. That's specified by the key, and the type of this object is the solar system. And the L colon here is the local namespace for that particular type in XAML. So object data provider can instantiate one of these objects for you when it's requested. It's a factory pattern. It'll hold an instance of that. And there are also other, you can also in XAML specify the constructor parameters or even call a method to return this particular object. So now that we have made this solar system available in the resource dictionary, now we need to be able to refer to it. And the way you do that is to use this binding expression, static resource, and the name of the particular static resource we have here, which is solar system. And I will be using that within the binding expression. So here, the text box, the text property is now bound to the path. The path is the object path to get to the particular property in the solar system object that you're looking for. In this case, is solar system, .sun.name. That's what I'm binding to. And then a particular source is the static resource solar system object that was returned by the object data provider. And we have two types of data providers that we supply. One is the object data provider. The other one is XML data provider. But you can create your own to say loading from the database or any way that any other types of data provider you want to implement. So in the example I had, so for all the properties, I directly associated that with a particular object, in this case, the sun object with name, and getting it from the static resource. But very often, you want to say that, well, this part of the UI really all share the data from the same instance of an object. And the way that you do that is by using the data context concept. So here, in the stack panel is a parent, it's a container for the image and text box. And I can say that everything inside the stack panel shares the same data context. And I can do that by saying that data context property on the stack panel equals to the sun object that we have in the solar system. And now with that, each of the text box and the image now don't have to specify sun.name and sun.image. They just need to refer to the path as name and image. Now because they are all sharing the same data context. So everything underneath the tree of a stack panel now will share the same data context. They automatically inherit that. You can override that by further down the tree by specifying your own data context somewhere down the tree. But this allows you to have, let's say, a form. They all share the same object, and you don't have to refer to that object specifically for each instance. Now this is very useful once we start looking at binding to collections, because now all I have to do to change how what this particular form targets is I'm going to target to a different object, and now all the children that using this this data context will inherit the different instance of the object. So in the first, yes, sir.
Does Blend actually do that, or doesn't you get type example?
Blend actually supports data context. Yeah, you can use Blend to. I should repeat the question. The question was, does Blend support specifying data context? And the answer is yes. If you go to data context, you can use data binding just like any other property to bind to, let's say, the static resource or dynamic resource or even another value. You can do that. So in the first example, the data that you saw there was pretty static. It doesn't change, and we're just pushing value in and out. But in a real object model, there are going to be value that changes because of computation, because of the fact that I'm collecting values, from external sensors, and I need to be able to notify the user interface that that something has changed, and to update so that user interface can update itself. So this is where the change notification comes in, and in this particular demo. In this particular demo, I have I'm going to simulate collecting temperature data from one of these planets. Obviously, it's I'm not really doing that for real, so it's going to be some random number being generated. So let's take a look at the code that that generated this this change. So I basically derive a class from planet that's called Saturn, and I added a dispatch timer that will basically call you back on the unmeasured temperature, in this case every second. And I'm going to start the timer, and And on measured temperature, I'm basically adding a random number to the average temperature of Saturn, which happens to be minus 270 degrees Kelvin or something. And what this does is I'm going to set the property. So let me just comment out this code for now. So if I just set the property, there's no way for the user interface to really know that this value has changed. So we need to be able to notify the UI that something has changed, and therefore, we use the .NET pattern of firing an event when this happens. So let's take a look at this code as it is now, with this commented out, and you see live data there, but that's before I compiled it. So now that I have compiled it, you notice that I'm not firing out the event change notification, and therefore the temperature doesn't change, which is what we would expect. In order to implement the change notification, what I have to do is to implement the iNotify property change interface. And that interface has one event, the property change event. And so when the temperature value changes, I basically fire this event that says, I'm going to call the event handler as new property change event args, and the name of the property, in which case this is temperature. And now when I compile this and run it, you will see that I'm getting notification from this event, and that's what's prompting the data binding to say, hey, look, this property has changed. I have a binding to it, and therefore I need to update. I need to update it. And in fact, the data binding mechanism picks up this change automatically. So there are two ways to implement this. The one way I showed you is to implement the iNotify property change interface, and you fire out that event, that property change notification. The other way, we actually support another pattern, which is that if you don't want to implement the iNotify property change, you can, in this case, you can implement a temperature change event pattern. And through reflection, we find out, oh, you have a temperature property, and you also have a temperature change event associated with it, and we can use that for notification as well. And in the case of collections, what we've shown is changes on the properties. In the case of collections, let's say I have the list of planets, and for some reason the list of planets changes all the time, like taking, I don't know, Pluto out of the planet list. You would implement the iNotify collection change interface, and that will have an event that you can say what has changed in this particular collections, where the items have been added, removed, replaced. And we have already implemented a very common collection called observable collections that has implemented this interface. As you add and remove items from this particular collection, it will go and fire off these events. So that's a very and that's very useful utility collections to use. We also support the binding list, which is kind of common to the WinForms type data collection, and when we do data binding to collections, we will also watch for those as well. Okay. So while data binding to properties are interesting, most people have more than just one object you have to deal with. So this is where binding to collections, is important. So this is how you implement list boxes, grids, or various other types of controls that manipulates a collection of items. So again, let's go back to Blend and take a look at how to do data binding on a collection. So Blend has a few shortcuts on helping you kind of rearrange the UI layout, and I just use the tab. Tab is a very useful shortcut to kind of take everything away from your screen. So what I have here is I have basically just dropped a list box on the screen, and it's not displaying anything. I want to display the suns and planets from the solar system. And you notice in the code here, I have placed the solar system as object to be instantiated as the value of the data context for the page. So now I go to this list box, and let's bring back the properties. Now what I want to do is I want to bind the items source for the list box to the collection of suns and planets. So list box is a items control, and items control basically is the underlying infrastructure for manipulating, for having UI elements that manipulates a collection of items. In this case, I'm going to data bind the item source to the solar system's sun and planet array. Now, you notice here, I'm actually getting the solar system from the explicit data context. That was the question that were asked before, instead of from the, let's say, the data field or the element property that we saw before. So now I've data bound to the to collection, and you will see the collection right there. Well, that's not really very interesting. Everybody can do that. So one of the things that WPF can do is this concept of a data templating. Now, what this particular list box is showing is basically the toString result of the items in that collection. So in this case, the toString that I wrote just returns the name of those objects. But that's not very interesting. I really kind of want to display more data for those particular items. And the data template mechanism in WPF allows me to select what I actually want to display for each one of these items. And we can change that in Blend. So if we go here, go to data binding, and I want to define a data template, for each one of those items. So in this case, I'm going to create a new data template and display fields. And here I'm going to say, I'll use, a stack panel as the basically containing panel for each one of the items in the list box. And I'm going to select what I want to display. So I'm going to have the name as the first item, display as a text box, an image. No, not a stack panel. I want it to be an image. I want to display, let's say, get rid of the orbit and move the details down. So you see the example on what you get here, and it basically generates a template for these items. So let's just look at the design. So here you can see that what I showed before is just string now really has more content for each one of these items. And in Blend, you can actually go and drill down into these items and edit them, edit the template, and kind of arrange this. And I won't show you that now. I'll just show you that I have, for example, I have already set up a template that I can reuse here. And let me just get back out on the list box. And I'm going to go back to the item source, data binding, define data template. Well, instead of creating one from scratch here, I would just choose one that I have already implemented. And in this case, it kind of lays out nicely, and you can really kind of visualize your data this way. So this is really the power of WPF and Silverlight. While we only have one list box, you can really change the way how you want to display your data in that list box. So let's take a look at what really happened there. So data templates is a way of kind of deciding how you want to display a particular data item in the UI. In this case, we have solar system object that has an image and a name, and we can define a data template. Data template has a key, so this is the name of the particular data template in the resources, and the rest is just kind of lay out how to display the data that we want to show here. So this data template is like a stamp that's going to be used for every item that you have in your list box. And the data context for this particular data template is going to be the particular object in that item. So this is where data context comes in, where I am reusing the same layout and data binding on different instances of objects. So in this case, with the data template can be used for a number of stuff. One, which is the item template that we saw before, but they can be also used for other types of controls that are not list boxes. In this case, you can use it as perhaps a control template where the control itself is going to be laid out this way. So how do you choose these data templates to use, right? We've seen the particular example that we had before. That's just by name. I'm explicitly specifying that I'm going to be using a particular template from the resources. But I can also specify, more similar to kind of styling, where to say that this data template really applies to this particular data type. So this allows me to use different data templates based on the types of object that particular items that I want to display is. So that gives me a way of kind of varying how to display things based on the data type. And obviously, data template also works for XML as well. So now, we've seen the basic use of data template. Data template is really much more powerful than that, and I can show you an example on how to really change what we saw as a list box into something that looks, well, nothing like a list box. So in this case, I've started out with the list box as we saw before, and I have data bounded to the solar system. So you see the list of suns and planets as before. Now, the list box has something called a items panel. This is how the particular items are laid out in a list box. Normally, a list box basically has a stacking, has a stacking panel that goes, top to bottom, left to right. But we can really change what that is. We can change it to, in this particular case, instead of a items planet, instead of a stacking panel, we change it into a canvas. Now, you suddenly see what happened here. Now, you notice that I've actually changed the way that the list box have been laying out these planets. Well, what happened? I just changed the items panels, change it from the stacking panel, which is the default, to the canvas. Canvas allows you to lay out elements by XY coordinates specifically. So the other thing that happened in this particular demo was that I wrote a style for the list box items. And this style basically data binds the canvas left and the canvas top property of each of the items. So this is basically the left and bottom position of how each of the items are laid out on the canvas that I just put in. And I wrote a little code here that kind of converts the the value of the orbit, how far it is away from the sun in astronomical units, and convert it to the XY coordinates, to display on this particular list box. I can just show you quickly what that code looks like. So this is just, again, using the value converter that we saw, which is now using a little bit of math on positioning it so that it fits in the list box. And now we have, just by adding the styling on the list box items that picks up the orbit value and translating that to the XY coordinates, I have now laid out my list box in a totally different way than the traditional list box. So the next thing I'm going to do here is that, well, you know what? The text doesn't look very good for these items. So let's change that to have a data template we saw before that displays the image of the planets. Whoa. Okay. Don't know what happened there. All right. So now what you see here is now the planets, instead of the names, is now displaying the images of planet. So I'm going to change the background here to black. And I'm going to do one more thing here. I also have some other code here. Well, wouldn't it be nice if I actually kind of show the orbit that the particular planets go in? So here, I'm just going to uncomment some additional styling code here. And let's run it. Yeah, thank you. Okay. Apparently, all the planets disappeared. Sorry? Item template. Oh, did I destroy a bunch of stuff here? Oh, there we go. Thank you. Good to have more than one pair of eyes on these things. And all right. Hey, there we go. Let's run this guy. Okay, so now this looks nothing like a list box, but it is a list box, right? And we actually get quite a few things from this for free. So I've changed my the styling so that the selection is not selecting the list box item, and it draws a circle. But I get like the keyboard up and down and all that type of stuff that a normal list box has. And this is where how this is really how we see WPF and Silverlight intersect between the developers and the designers. Because as a developer, what I needed to do was to implement the solar system objects, maybe give information about what properties are available, and maybe help the designer write the particular converter. I can then designer using Blend can actually take this and write either using Blend or writing the XAML code that I saw just now to really restyle your controls. So you may wonder, why does WPF not have all sorts of different controls? Well, you can change the styling yourself. So it's really not necessary. The controls themselves are really kind of the underlying code for manipulating the data, but the actual styling itself really comes through templating and styling. And I can change an existing button to a button that takes images, that flashes, whatever it is, without actually changing the button C# source code itself. So now that we have a collection and we can display it in a list box, that's typically not quite enough for kind of really visualizing lists of data. You might want to sort it, you might want to filter it, you might want to group it. So what we can do in WPF is that we have something called a collection view. So every time that you put a collection into an items control, what we do behind the scene is to create this wrapper called collection view on the list of items. That collection view allows you to have a lot of functionality of manipulating the particular collection for display without you having to write it. You can, of course, kind of go and write a new collection type yourself, do the sorting, and present it. But we've done some of that work for you. So I'm just going to run this. So this is give me a sec here. All right. So collection view, this is actually live data here. So I have this user interface that I showed you before, the list box, that use the particular data template that we showed before. So underlying this, so this is just basically what the order of that particular collection was. And the way that I did this was I apply a little transform to the list box so that it gets tilted and look a little bit 3D. And you can do all sorts of stuff. You can actually put this in real 3D if you really wanted to. So underlying this is really the view to this particular collection. And I can, for example, select to sort these by diameter or filter out only the small planets. Or group them by size. So these are all, so sort, filter, and group are some of the functionalities that the collection view supports. So let's take a look at how some of that stuff actually works. So let's go to the source code here. So the page itself is a collection view. So the first thing that we did here was that I took the default view of the for the solar system and sun and planets for that particular view, and the various event handlers that I implemented to deal with the clicking basically takes the collection view and apply, for example, a filter out small planet predicate, or adding the descriptions on saying I'm going to be grouping based on diameters, remove grouping, and various code that kind of allows you to really manipulate this collection of this collection view. So the collection view wraps the underlying collection, and every items control by default creates a collection view, and you can get hold of that and do this type of manipulation. And in XAML, you can also specify this using something called the collection view source that allows you to do grouping and sorting and markup. Unfortunately, this is not available in Silverlight 2. So in Silverlight, if you wanted to do the equivalent, then you create your own collection, maybe using link to do the sorting, and then applying that to the items control, the list box. So another very common pattern in user interface is the master detail view. So this is where I have a list of items, and for every item I want to drill into the detail and manipulate that. So what I've done for this particular demo is I reused the list box that we just saw, the fancy list box with the orbits and stuff. And I have added another panel. In this case, I started out with just having a text box for the name. And I put this in a content presenter. This is to allow me to tie together the selection of the list box with the values here. So when we first run this, not much happens. They are not really tied together. The text is just showing the name, just the first item in the list. So let's take a look at the particular code here. So if you look at Content Presenter, that's kind of interesting. Content Presenter is not an items control. It's not a list of, it doesn't deal with a collection of items. But I have bound it to a collection. So what does that actually mean? What that actually means is that I'm binding to the current item of that collection. So the data binding mechanism, so you can do this for basically any other types of control. If I bind a collection to something that only expects one item, what the data binding mechanism basically falls back to say, hey, look, this is, I don't know anything about a collection. What I really want to do here is look at the current item, and then all the path are going to be based off the current item. Now, the next thing I need to do in order to tie these two together is to uncomment this line of code. It's synchronized with current item. So what that does is that the particular list box in this case, Sun Planet Control is a user control based off the list box and based off all the templates that you saw before. So list box is going to synchronize the selected item, with the current item in the collection view. So how are these two tied together? Well, they're both based on tying to the same. The item source for the Sun Planet Control is the same as the item source for this content presenter. So what happens is, because they're both pointing to the same place, and you say it's synchronized with current item, and we get that fallback behavior of the collection back to the current item, we get automatically updated, when the current item changes, selection changes, current item changes, and therefore the data binding changes. So if we run this, with very little code, now I get data binding of the text box to the currently selected item in the list box. And obviously, one particular field is not that interesting, so we can go and uncomment some more stuff. Oh, wish I get that type of applause. Okay, so now you can see I actually have more data here, and this, just to show you, this is live data. This is I'm going to use my magic and move Neptune to, let's say, 25 astronomical unit. You can see that these are real life data, and I can change the name. I need a planet named after me. So, these are live data there. All right, so in a very simple way, you can implement master and detail type UI. So just to review what we did, for items control, you use an items control as the master. So this is where the selection comes in. And we set the is synchronized with current item to true. That makes sure that the selection is tied to the current item. And other bindings based on the same source, in this case, the sun and planet stuff, based on the same source, will basically follow the current item. There are other ways to do this binding as well. I can obviously data bind directly to the selected item or the selected value in the list box. But now that type of implementation now start binding different parts of the UI together. And you can do it, and sometimes you have to do it because your UI gets pretty complicated. But it tends to be pretty fragile, right? Because now I'm relying, one part of my UI is now relying on the fact that another part of my UI has a particular, behavior. So, ideally, we kind of take those things, bring it down one level into a view model that is more kind of abstract, so that a designer can go and decide, well, I don't want to use list box, I want to use my fancy, my fancy list box instead, and won't break this type of behavior. The other type of UI paradigm that's really common are displaying hierarchical data in a tree view. So we can take a look at how that works. Okay. So I start by having a tree view, and I'm going to bind to the item source is the solar system as we saw before, and the list of sun and planets. Now, you see that just by doing that, I basically get the first list of items there. But the tree view obviously has no idea how to drill down into the next level of collection. So the way that we do that is that we supply a hierarchical data template. So a hierarchical data template basically is similar to items data template in the sense that it lets you specify how to display one of those items. But it also does one other thing. You can specify the item source of your children elements. So if you look at the code here, I have the item source here with the binding path to the moons. So moons is a property that returns a collection of the moons for for the planets. And the data type here is bound to a solar system object. Now, this data, by specifying data type here, I can actually select between the different types of data templates, right, based on the type of data that you have in that collection. So that's actually very powerful, and you see this. So here, if I just run this, there we go. Now I should get the list of moons, and you can kind of extend this. Imagine if moons have moons or moons have other stuff. You can kind of just go on down there. So the next thing you want to do is, well, I really want to display each one of these levels kind of differently, right? So there are several ways of doing that, and I'll show you one here. So first of all, I'm going to comment this and uncomment this. Now, this particular data template here is similar to the other one, except that it kind of makes it look a little prettier. adding little items, images there. But now, I still haven't done anything for the moon yet. So I'm going to add another hierarchical data template. Now this time, I'm going to target the subtype of the solar system object that's the moon. So now, the data mechanism, finds out, hey, there's a better suited data template for that. And it will use that instead of the other data template. So now I can have, at different levels of my tree, I can have, different data templates. And there are a variety of ways you can do this. You can also specify, instead of using this data type matching, I can also explicitly specify an items template for my children. So just quickly go over what we've done before. So in this case, the particular example on the screen here uses a XML file rather than real-life objects. So you'll be referring to things like by XPath rather than paths. But the tree view, the item template for this one is now the hierarchical data template as we saw before, and we specify the item source to say how do you drill down to the children. And in the case of XPath, it's, you use that particular syntax, and what you get is that. So now we've basically seen most of the common patterns in how to bring UI in WPF and Silverlight, and you can see that data binding combined with the templating mechanism really allows you to change the way that your data interacts with the user interface. And I think that's a really powerful idiom in WPF. So a combination of XAML being the textual format, declarative format for describing how to lay out the UI, the templating mechanism, both for control styling, for items templating, allows you to change and skin the particular how you want to visualize your data. And then the data binding mechanism that gives you a declarative way of connecting your user interface to your data model really gives you this ability of separating how a designer goes and takes all the object models and computation logic that the developers have written and kind of present that in the user interface. So just a quick kind of overview on some of the new stuff that we did in the .NET Framework 3.5. Data binding has been around since we first released, and it's always been a little bit difficult to debug. You go to the output window to see binding. We've added kind of trace level attached properties so that you can actually have better control on the types of information you get from your data binding. Data error info. So one of the things I did not cover in this particular talk was data validation. One of the things that the data binding supports is validation of data. I have typed in the wrong credit card field. My planet is way too far outside of the solar system. So those are data validations that the data binding mechanism supports. And one of the things that we've done in 3.5 is to support the data error info mechanism that's been around since window forms that allows the business objects, your data model, to fire out an exception and provide this information to say that I cannot set that property, and we can present validation errors that way. And we also have some updates to the data validation syntax. And finally, one of the most important things is link. Link came out in 3.5, so we support. Data binding to results of link, I enumerables, and we are much more in 3.5, we're much more intelligent about how we data bind to IEnumerable rather than enumerating through the collection multiple times. We take snapshots of them, and the performance has improved tremendously. To summarize, we've really built in this data binding as really a core architectural principle in WPF, and because user interface is really all about presenting data, and so this is really a very core part of both WPF and Silverlight. So templates, as I mentioned before, that really allows you to skin or to visualize your data in a way that is appropriate for that particular data. And this is very different than the other user interface frameworks, because now a list box isn't a fixed presentation of a list of items. You can actually use templating to show it that's most appropriate to your particular set of data. So if you look at the way that controls are written, right? There's some underlying code in C#, for controls, and then there's the styling, and the templates that we saw before. So the way that we've structured this is that the code part really kind of understands data. So in this case, we have like items control that deals with a collection of items, and then we have, and then we derive from that to say that. This is a list box versus a menu. They're all items control, but they all kind of, base off the same model of dealing with collections of data. And then on top of that, we apply styling and templating that makes it look like a particular type of control. And that's really a core concept on how to manipulate your user interface, to suit your particular application. Well, thank you very much. Please don't forget to fill out the speaker evaluation. And if there are any questions, please come up to the mic.
Hi. I do a lot of work in WPF, and one of the things that I've had kind of problems with is having a data template, attaching it to properties, or attaching it to something, and then having it be generic. Kind of something where I have a style that I like, but I have to bind it really specifically to that specific piece of data, and I don't want to. I want to make it so that I can use it kind of across the board.
Okay. Can you? So the question is, you have a very specific data template for a particular type of item, and then you have some generic styles, for that, that you want to reuse across different data templates. Right. Well, one thing is, exactly as you said there, you can kind of separate the style being applied to the particular data template, from the data template itself. So for styling, you can either apply it based on type, or you can be specifically choosing it based on the resource name. Is that something that could help you there?
Sort of, kind of. I'm thinking specifically, for example, when I create a list view and I go into the header and I say, okay, make this header do this kind of thing. Right. For example, text wrapping. Every time I do that, for every header that I make, I have to have a separate data template that says, okay, you need to bind to this very specific data piece. Okay,
so you want to put that data template in the list box resource. Right? But you have multiple list box that wants to reuse the same resource.
The same.
Dynamic resource, would that help?
Okay.
Perhaps. So we can probably, I would suggest that we probably chat afterwards and see if I can help you there.
Is there a way we can get the code for all the samples that you just had?
Yeah, let me find out what's the way that we distribute this, and yeah, I'll be happy to put that out.
Maybe you can put it on your blog or something, or.
Yeah, actually, a lot of this sample came from one of my team members, Beatrice Costa, and she has a real blog that talks about a lot of this stuff. and we can put out that information. I think if you go to windowsclient.net, I think there are probably links to that.
Okay.
Okay, thank you.
Hi. Can you clarify again, the properties that you had on your planets were not dependency properties? Or they were?
Oh, the planets themselves, no, they are just regular CLR, there's regular CLR properties. So the question was whether the properties on the data model have to be dependency problem. No, they don't. It's only the targets of the data binding. So in this case, the UI elements are the dependency properties.
Oh.
So that's why you can basically use any object that you have that is not WPF aware as a source of the data, and only the WPF UI elements needs to be dependency objects.
Thank you.
Okay.
Hi. Can you have master detail relationship with relational data, like two different data tables with a child relation or something like that?
Can you have master details?
The master detail example that you showed was working with one set of data. It was the same collection.
Right.
So if I have two tables, let's say order and order item with a relation set to it, would it work the same way?
So the reason why the two are tied together is because they share the same instance of the item source. Right. So that collection, they are basically both working against the same collection. So if you have if you want to display two unrelated master collections, they will
I'm
not.
talking of the same. I'm talking of related data. Let's say order and order items. So
Okay.
they're related by let's say order number. All the order items have the same order number. And would the master detail example that you showed, would it work still the same way with two data tables?
So I'm trying to actually understand your particular scenario here. So we have two tables, and depending on whether you select it from table 1 or table 2, are these in two list boxes?
You select rows from table 1.
Right.
And table 2, let's say there are 10 orders, number 1 to number 10.
Oh, so you have a
you select the order
cascading
number.
you have a cascading list of master details. You actually have to do a little bit more work there. Again, B. Costa, the blog actually has specific information on how to do cascading master details. There are multiple ways. You can basically, as I mentioned before, data bind the selection across the controls. You can share some common view model where you basically push down the current item and that you read it up, and then that's actually kind of architecturally how I would have approached it. And you can also do it, in XAML as well, with some, I would say, not quite as obvious relationship. But the way that I would approach this, I would actually write an object model that says this is the current order, this is the current line item, and then you data bind to that as a view model, right, for this particular thing, and then with that data binding, you don't have direct relationship between the UI elements because you still abstracted out the fact that I'm dealing with current orders or current line items out of the particular UI layout. But that's also that will become reusable, and it's also much more obvious about what you're dealing with. So basically, a selection object, if you like, that have this information, and the page can basically use that as like a data context, for example.
Thank you.
Thank you. Well.
One more additional question, please. With regards to fairly large data sets and long lists of enumerations or collections,
right,
are there any special considerations you have to take to deal with that?
We support UI virtualization so that we don't actually go through your whole list just to display that. And we're actually doing quite a bit of work there in terms of performance, on kind of recycling, containers and that type of stuff. So you'll see continued improvement there. But even in 3.5, we have UI virtualization. You can turn that on.
Is that something you have to physically switch on?
Yeah, that's something you have to physically
Okay,
switch
thank
on.
you.
So.
So I got one question. Is there any difference between about data binding between WPF and Silverlight?
So Silverlight is basically a subset of the WPF functionality for data binding, and most of what I showed you there is actually applicable, across the board. And the one example is the collection view, and there are also some other differences. We're still kind of finalizing, the exact compatibility between WPF and Silverlight, and I'm sure we'll be giving out more guidance in terms of what aspects of data binding is common to both. But that's something that we're still working on. So.
Okay. And the current blend version, does it already support data binding for Silverlight, or is it not?
Well, you will need the blend 2 beta to support Silverlight. That's what I'm using here. I'm actually using a December version, but there's a newer version that we just announced. But I didn't want to use that for my demo just in case. So that's right. Yeah. So collection view doesn't exist in Silverlight. You can just, as I said, you can use link to do some of the equivalent stuff. So.
I know that data virtualization in the WPF controls isn't really there right now. But could you speak to how maybe you would go about doing that, or when that's going to be?
Well, we do have some support for that, and a lot of it depends on the types of the particular type of data virtualization that you're talking about. I would say that if you have to do it now, for example, let's say the tree views and stuff, you can watch for events on the node being closed and get rid of those and open and do that type of stuff. So we are actually doing some work that kind of supports kind of much larger data sets coming out soon actually. So
particularly what I'm really interested in is the list controls, for example, to just infinitely scroll as you get to the bottom of the list. Right now, doing it by just you're getting close to the bottom. I'm going to go jump and grab a new set, add it to the collection, but.
Yeah, I mean, at this point, that's the level of support we have. Maybe Rob here can. So this is a data virtualization support. Do we have something new in 3.5 for infinitely scrolling list boxes?
No, we've got the recycling thing
Yeah.
you mentioned earlier, but the data virtualization we're not.
Yeah, we're not quite there yet. So definitely, at least for kind of unbounded list of items, but you have stack panel, right?
Thanks.
Okay.
Hi, I have a question regarding how XAML instantiates your objects.
Yes.
So, like for instance, if I have an object data provider in my resources, it doesn't instantiate that until it's bound to.
Right.
Is that correct?
Right. So XAML basically, in order to bring up your UI, basically we're instantiating all the objects, in XAML, and then we set the properties of those objects. So that's basically how we parse, the XAML and instantiate the objects. So the object data provider is basically a factory pattern that that what you instantiate is the object, is the object data provider. But you can actually, but the actual instance of the object isn't created until it's being accessed. And in fact, object data provider also has is a sync property that allows you to that actually, if your object takes a long time to instantiate, we can do that on a different thread and move it back before we data bind to it.
So would that asynchronous operation not happen until the binding takes place?
Right.
Okay.
They won't get initiated until that happens, yeah.
Okay. Does that work differently than when if I stick an object directly in my data context?
Right. So in the example that I have there, that if you directly stick a instance of an object in the data context, so while we are building the UI, that object gets instantiated just like one of the controls that you see on your screen there. So.
Okay. Well, I have one more follow-up, then I'll leave you alone. So say I had a real simple app where I could realistically bring in all my objects in memory right up front, and I wanted to do that asynchronously. How would I do that? Because if I stick it in the resources, it's going to wait until it binds to it. So it's going to wait till all my screen objects have been created, for instance.
So you want to bind to asynchronous?
So I want to go fetch my data asynchronously using an object data provider, but I don't want to wait until all the bindings are asking for it, if that makes sense.
I think, yeah, I kind of, I understand what you're saying there. I'm not sure you actually see any difference from the user perspective, right? Because the moment that you get, so you can do all this yourself in code, right?
Perhaps maybe if I would be sticking these object data providers in my application resources,
right? And
then I have a screen later on that's going to bind to it.
So what I've shown here are kind of setting data context and stuff all in XAML. You could actually say, I mean, it's just a property on one of the objects, so you could do this yourself. And on your startup path to your application, you can go and create a different thread, do that, and then bring it back. So from the user perspective, if you think about it, that's not that much difference if your screen comes out right away, and then your data binds to it, and then we go ahead and do it. It's not that much difference, but if in your case there's a big gap between your startup time and where you actually bring your UI up, I would just go ahead and do that myself, separately. So, okay, thank you very much.